Hello and assalamu alaikum everyone. I hope you all are fine. I'm here with the next question, that is question number 108 regarding strength of material, um, or you can also call it MOS, mechanics of solid. So the question is, an aluminum rod is rigidly attached between a steel rod and a bronze rod as shown in figure P108. I will show it later after this. I read this question. So axial loads are applied at the positions indicated. Find the maximum value of P. So we need to find P that will not exceed a stress in steel of 140 megapascal. So for steel you've got limit of 140 megapascals of stress. For aluminum you've got 90 megapascal of stress, and for bronze you've got 100 megapascals of stress, and we need to find the value of P. So this is your diagram. This is on page 13, that's why I need to switch to page 13. So you've got this side fixed, you've got steel bigger block having a bigger area, that is 500 square millimeter, having a bigger load of 4p, and then you have attached aluminum, which is relatively smaller than steel, having area of 400 square millimeter, distance of 2 meter. This one is 2.5, a bit different, and having a tensile load of P. Then you've got bronze, which is also smaller than aluminium, which is 200 square millimeters, and you've got compression of 2p here. Now let's go to your answer, and here you have got solution to problem 108, normal stresses, strength of material, this. Okay, now you've got given things are, these are your allowable stresses for steel, for aluminum, for bronze. Now what they need is, you need to find out maximum safe value of axial load P. So this is your diagram, what we call it, it is free body diagram. So all the things are mentioned here. So what you need to do is, you need to definitely find out P, which is pretty easy. You will be noticing that all of the formulas that we are using are stress is equals to load by area. The diagrams are changing, some requirements are changing, but the idea behind all this is the same. So here again, if got stress is equals to load by area, so you need to find load. We transfer it to A. Here we transferred A here, and we placed 2p instead of load, because you've got 2p of load here applying on the bronze. Now place the value of stress here, which is, you can see for bronze it is 100 megapascals. For area is 200 mm square. So when you multiply it, let's multiply it, it's easy, but I'm just doing it for you. 200 into 100, you've got 20,000, and you need to divide it by 2, you've got 10,000 Newton load. Now for aluminum you've got the same formula, but stress is different. You can see it's 90 megapascals, and area is also different, and there is no 2p, so you've got 36,000 Newton. And for steel you've got 5p, and stress is how much, 140 megapascals, and area is 500 square millimeter, so it yields 14,000 newtons. Now all of these, from all of these, which one of B is you want to select? So the basic idea behind it, when you place this thing in a real life and you apply all these loads, and you knew that bronze can support 10,000 Newton, aluminum can support 36,000 Newton, and steel can support 14,000 Newton. So if you apply load of 10,000 Newton, there will be no failure. Okay, everything will be safe, 10,000 or below 10,000. And if you apply 14,000, bronze will fail because you have exceeded the load. Similarly, the same 36, so 14,000 and 10,000 both will fail. So you need to select 10,000 Newton. You need to suggest that 10,000 Newton is safer. You're not allowed to exceed load 10,000 Newton. I hope you get it. If you have any questions, please do ask. Feel free to ask in the comment, and if you have any other question other than these mechanics of solid questions, I'll be really glad to solve it for you. Just tell me in the comment and I'll look into it. Bye bye for now. Assalamu alaikum.